Today we're going to do what I like to call a coding challenge. And I like these coding challenges because, it gets you to stretch a little bit and kind of think outside the box and maybe solve problems that you haven't really thought about before. So there is a site, it's called Code Signal. It doesn't really look like it's pushing new daily puzzles, but there's a lot of kind of older puzzles that are there that you can work on. And how it works is, they give you kind of some requirements or some information on the left-hand side about what you're trying to solve, and then they give you these automated tests. So at the end, you click Run Tests, and your goal is to make all these tests pass. And right now, obviously, I have an error. So we're going to start just by kind of reviewing this. And this particular thing is called electric field. Here's the URL for it. So I don't know if that's too small. I'll push it here for now. So there's the URL. So if you need that a little bit bigger, you can see that there. So I like these code challenges because there's a little story behind them and it kind of give you technical details, kind of like real world problems. So if you haven't done these before, you kind of read through here and you kind of understand the problem. But essentially, they kind of stub out a solution and you're going to be passed two parameters, a grid and wires. And so they tell you down here what the grid and the wires are. So a grid, for example, is a 2-element list, and wires is a list of lists, right? So that's kind of the definition. And then it's telling you the output should be, looks like an integer. And I'll let you read through here at the top, but essentially what they're going to do is they're going to tell you a grid size. So grid is coming in and it has two parameters. The first element is the height, and then it's the width. So this example is height is 4, width is 8. And so you can get a 4x8 grid, or an 8x4 grid, however you want to say it. And then the second parameter, wires, kind of defines these red lines. So for example, this is x1, y1, x2, y2. And so 1, 0 is 1, 0, that's that point right there. And 1, 3 is this point down here. So this first set of values, x1, y1, x2, y2, define this red line right here, or that wire they're calling them. And then you can see kind of, for example, 3, 1 and 3, 2. So 3, 1 and 3, 2, that defines that wire right there. And so you can kind of go through here and you can see all these wires. And the goal is to write some code so that if you start in the upper left-hand corner and you're going to end in the lower right-hand corner, what's the shortest path? You got to make decisions. Obviously if I start here, I can only go down. That's the cell I can go to. That's the only cell. Then I'm here. And so then the next cell is I can only go down. The next cell is I can only go down. The next cell I can only go to the right. And so I keep following this until I get to about this cell right here. And then when I'm in that cell right there, I have two choices. I can either go to the right or I can go up. And so I have two choices to go here, but I can't never cross a red line. And so I'd have to explore this path to the right until it comes to an end and I can't go any further and I know that's a dead path. But then eventually I would come back to this path. And then again, over here, I would have a choice. Do I go to my right because I'm facing kind of down here? Do I go this way or do I go bottom? So I can keep going all the way to the end and eventually I would end up at the final square. All right, so with that in mind, let's write some code here. So I think these types of puzzles are complicated enough where if you can write some classes and have objects that have meaningful methods on them, that's going to make it a lot more clear. So that's what we're going to do. So first thing we're going to do here is I want to see, we're just going to print grid and wires. I want to see what they look like just to make sure that we're seeing what we see. So again, you can see when I run this now, you can see that I'm getting some tests and it says the wrong answer. But what we're going to be guided by are these tests. So again, we don't know what the code's supposed to look like. There's probably thousands of variations of correct code, but we do know that the return value for this first test is going to be 26, and we didn't return anything. So that's how it's going to go. So if I put return 26, I can make that first test pass. So if I run the test again, I'm going to get a check on the first test, passed it because I returned 26, but the rest is out. So anyways, I am printing console out. I'm printing these things. I can see here's the grid and here's the wires, and that's also on the input, so I can see grid and wires on the input. Right now this particular grid isn't really very meaningful to me. What I really want to do is I want to create an object that kind of maintains the structure, and then I can ask it questions about each cell. So I think the very first thing I'm going to do is I would like to be able to write some code like this. I want to create a grid that takes grid and wires into a constructor, and then it will essentially create this kind of object, and then I can ask it questions like, hey, if I'm at this particular cell, what are my next available moves? I can move up or I can move down. And so that's kind of the first step in this process for me, is I want to create this kind of code. And so I'm going to create a class for this. All right, and this class is going to have a constructor, and it's going to take grid and wires as inputs here. And then I think what we're going to do is we're going to extract the height and the width. So from the grid variable, we can create these internal variables called height, and that's the very first index of grid. If you remember, we saw that here. Grid's an array. The first element in the array is the height, and then the second element in the array is the width. So I kind of imagine that now that the next step for this constructor is to initialize this object and build some representation for this data. So what we're going to do is we're going to create a couple of private methods. One's called maybe create grid, something like that, and that's not going to take any parameters because I'll know the height and the width, and that's all I'll need to know for that. And then the other one is going to be maybe something like called lay down or lay wires. Or set wires. I like that better, set wires. And this one will have to take one parameter, and we're going to pass the wires into it. So the next thing we're going to do is we're actually going to implement those functions in this class. So that'll be the first one, and the second one will be like that. So far I've got this thing. I need to fill out what these two things look like, and we're going to do that next. So for this create grid, oh, and I forgot, wires takes a parameter, right? So wires is going to be fed into there. So that's really what the second one looks like. So I've got these two kind of stubbed in here. Let's actually replace this pass, and then we'll actually fill it in. So eventually what I want to do is I want to have some representation for all of these cells. And I know the number of cells is going to be the width times the height. So that's the number of cells we have. And then what I want to do is, in my mind, I think I have like a dictionary where I'm storing data about every cell. So this cell, I would have data about kind of the top border, the left border, the right border, and the bottom border, just indicating to me whether or not, those are passable. And so that way I can use that information later on. All right, so first step is I'm going to create kind of a list that would hold all that data. So I have this cells list that is just kind of empty for now. All right, so the next thing we're going to do is we're going to populate each of those cells. So we'll just kind of set up a loop here. And so for every single cell, what we're going to do is we're going to define what the cell actually looks like. And again, I'm going to have a dictionary, and this dictionary for me is just kind of a representation of the data. And we can represent the data in a lot of different ways. You could just have a list here. For me, a dictionary just feels a little more kind of verbose, and I like that feeling of having a verbose. So for every single side, what I'm going to do is I'm going to have a Boolean that represents whether or not I can pass through that side. So top, we'll just initialize it as true, and I'm always going to kind of go around top to the right. And we'll initialize this one as true. Bottom, set it to true. And maybe the, I guess at least left, right? So that will be our cell representation. It's just a dictionary. And for every single side, I'm just saying whether or not that side essentially has a wire or I can pass through that side. So we're going to just append this to the end of our kind of cells list. So one of the things that we have to do now is we have to be able to initialize, for example, the borders. So the ultimate borders on this side and the bottom and the right and the top, those are boundaries, not necessarily wires, but those are boundaries that I can't go through. All right, and then we have to lay those wires on top also. So I'm going to have to go through this list of cells, figure out which one of these cells is, for example, here on the left-hand side, and then I'm going to have to set those boundaries for kind of these left sides of these cells to false, so that we know that we can't go that way. To be able to do that logic, I need to be able to index into our list, and given a particular x and y value, so this particular cell is located at x equals 0 and y equals 0. And so given an x, y, I want to be able to find the cell that's in our list. So we're going to create a helper function as part of our grid class that kind of gets us the cell. So we're just going to call it getCell, and it's going to take an x and a y value. So essentially we need to create an index, and then once we index into the list, we will be able to pull the particular data for the cell that we desire. All right, so first thing is I just want to kind of do a little bit of boundary checking here on these x and y values. So if x is like less than 0 or x is greater than, I guess it's the width minus 1, then I'm going to return none for this because that's out of bounds, right? And same thing for y. We can write some similar boundary conditions for y. So if y is less than 0 or y is greater than the height minus 1, then I'm going to return none also. And if it's not, then I get to compute an index. And so this index, I'm just going to use this equation. There's a couple of different ways you can do this, depending on how you want to lay out your, I can't type today. There we go. So this equation essentially is allowing the elements to be arranged in rows. So this element is first, this element is second, this is third in the array, fourth, and then when you get down here to this end, it goes to this cell next. And so that's how the elements are arranged. So once I know this index, then kind of the work is done. I just need to return the cell that is at that index. And so with this function, I can figure out which cell. So what's remaining here is I have to initialize the borders. So the top border, the bottom border, and those are fairly easy to initialize. So what I'm going to do is I'm going to run a variable x for the range, and x is going to be kind of this going this direction, so it's the width. And so I have the width already. And so what I'm going to do is for these x's, I'm going to find this top cell, and I'm going to set the top border of the top cell to false. And then I'm also going to find the bottom cell going in that direction and set the bottom border of the bottom cell to false. And so that's what we're going to do next. So we're going to find the next top cell. We're going to use our getCell function. And it takes xy value, so the x is fed in, and the y at that top cell is 0. So then once I have the top cell, I just have to use the dictionary, right? I'm going to set top equal to false. And then similarly with the bottom cell. So here's the bottom cell, same thing, self. We'll use our helper function, x value. But so y is going to be kind of the bottommost y value, which is going to be height minus 1. So once I have the bottom cell, then I'm going to use our dictionary, and I'm going to set the bottom value to false. And then we're going to do something similar. I'm just going to copy and paste this code. And what we're going to do is we're going to do y is going to change from 0. So we're going to switch this up a little bit now. So we're going to go over y from 0 to height. So it's going to go here, and we're going down. We're going to find the left, and we're going to find the right cell. So we're going to go down, we're going to find the left cells and set the left border to false, and then we're going to go down, find the right cells, and set the right border to false. So at this point, our create grid function has initialized the cells, and we should have all the edges set to false and all of the inner borders set to true. So before we get to add wires, I realize I'm kind of a visual person, and I want to be able to visualize this and make sure, that we can kind of see something similar to this. Obviously, our output is on console output, but I want to be able to maybe say something like grid print cells or something like that, so that we can actually visually see the output of our grid in this console output. Right now, we were just printing, the current grid values, but we don't need this anymore. So I'm going to go and get rid of this. But I do want to be able to print these cells. So let's go up and let's see if we can add that in here. I'm going to add it under get cell. So I'm thinking what I want to be able to visualize is, for every corner, we'll put a little plus sign. So plus would represent a corner of a cell. And then you either have like a dash or maybe a pipe symbol, that represents sides. So given that, I think that this is going to look out like if you had like a 2x2 grid, imagine that. It would be a corner, a top, a corner, a top, and a corner. And then I would get a side, I would get an empty space for the middle, another side, an empty space, a side, and then I would get the bottom of those cells, right? So every single cell would print kind of like these. And that would be like a 2x1. And if it was a 2x2, the next cells would have similar things, and it would kind of look like this when we're all done. So I have this is a cell, and it has a top, a right, a bottom, a left corner, or a side, and then same thing. This is a cell, this is a cell, this is a cell. So this would be row 1 of cells. That right there's row 1. Here's row 2 of the cells. So that's kind of what I think we're going for. So to be able to print this out, what we're going to have to do is we're going to print an inner loop going from left to right, and then an outer loop going from top to bottom. So our outer loop is going to be for y in range of the height, and then our inner loop is going to be for x in range of the width. And then I'm going to have to be able to print, each of these, what these things look like. The first thing I can do is, given I'm going to loop over x and y, I can get my cell using our helper function, right? So I can use this get cell helper function and feed in x and y, and it'll give me my cell back. So as I start to loop through here, eventually I'm going to have to print out like this top string. I'm going to have to print out this kind of middle string and this bottom string. So I'm going to maybe define these here as, top string, and I'm just going to set it equal to, initialize it to this. The mid string is going to be this, and the bottom string is going to be this. And then when I'm all said and done with that inner loop, what I'm going to do here at the bottom is I'm going to print the top string, and then print the mid string, and print the bottom string. So in my head, I think that's what we're heading towards, something like that, right? So that, we can go this top string, this middle string, and then that bottom string, and I'll print those out. So now we just have to kind of build up these strings inside the X loop for every cell. What I'm going to do is I always start with a corner, right? So I'm going to say that top string, I'm going to add a corner to it, which is going to be our plus symbol. All right, so as I build this up, I've got this top thing. I'm going to start with that. And then the next piece is I'm going to either add a dash or it's going to be a space. And up here in our representation, we didn't quite do it right. Here, I put walls up on every side of the cell. That would mean I can't go anywhere. But the reality is if I start here, I might be able to travel to the bottom cell. So that might be open and that might be open. And then maybe this is open. And so I'd start here, and I know I can travel bottom, and I can go this way, and I can get over to this cell. So that's kind of what I want to end up is. That's more realistic. If the walls are there, I would know. And so what I'm going to do is have just an if, if our cell and the top of it, because that's where we're at right now, is we're looking at the top. If it's false, that means that cell is closed, and I want to add to the top string a wall. Otherwise, I want to add to the top string a space. I think that makes sense. And then this top string, just to close this cell off, I'm going to add another plus sign. So for every cell, that top string, I think we're all good. So let's think about the mid string now. And I think we have to go right away to our if. There's nothing guaranteed about kind of this middle area. So if the left edge, so if my cell left is equal to false, then what I want to do is show a wall. Else, I just kind of leave it open, right? So I'm going to add a space or... After that, then I'm actually in the cell itself. So I need a space just to represent the cell. So I'm going to add another space here. And then I carry it over to the right wall. And again, if it's a little false, this is the right wall, it's closed, else it's open. So we got the top string done. Here's the top string. Let's just put some helper things. Top string is right there. Here's the mid string. And now we're going to do the bottom string. Bottom string is a lot like the top, so we're going to kind of go along this bottom edge here. So first thing I'm going to do is I'm going to place a corner. Next thing I'm going to do is I'm going to look at the bottom wall. And if that's false, then that bottom wall is going to be closed. Else that bottom wall is going to be open, and then I have to finish with the bottom string having another corner. And I think that'll do it. So let's just go ahead and run this and see what I get for our representation. So I'm going to run this test, and I get an unexpected error. Okay, so line 21, expected after function definition 148. Well, line 148, line 21. Let's do line 21 here. It doesn't really like my where I put my comment, right? It's not really indented properly. Let's try that. Okay, so we get an execution error here, and let's see what the output. Has no attribute set wires. So set wires, do we not call it that same thing? Create grid. We called it add wires. So let's try it again. Okay, so I'm getting wrong answers. Let's just see what our representation looks like. So this first grid for input 4-8, which is this one, 4-8, it should look more like that. And I get 8. So there's 1, 2, 3, 4, 5, 6, 7, 8. I'm getting 4. My wall right here, the border on the left side is not in the right spot. So let's go, we're initializing these borders. Oh, here's my mistake. So it's really the left cell. I want the left border. So let's run it again. And this is why I think that visualization is important. So now that looks better. So far we haven't laid any wires in the internal bits. So I just get borders along the outside, and I get, here's one cell from here to here, this corner, that corner, and I can see kind of all the internal walls are open. So this visualization is going to help us later on when things get more kind of complicated and we have to kind of troubleshoot. So I'm glad we did this. There's a lot of extra, not a lot, but there's a little bit extra code here. I'm going to go ahead and just kind of leave that the way it is right now. And let's get back to our set wires now. So now we have these wires, and again, our wires come in with x1, y1, x2, y2. So what we're going to do is grab those variables from the array, x1, y1, all right, and then the other thing that we know about these wires, like for example, take this vertical wire here. This vertical wire is going to impact the walls for the cells to the left and to the right of it. And so it's this cell and that cell. And same thing with horizontal wires. Horizontal wire is going to impact the top of this cell and the bottom of that one. And so let's go ahead and figure out whether we have kind of horizontal or vertical wires. So, you know, if we know x1 is equal to x2, that means that the x values aren't changing, and this is going to be a vertical wire. Else, we know that we're in the horizontal wire case. All right, so let's look at the logic for the vertical wire first. So these vertical wires, if like maybe I get this point right here, and it says it's going to run from y equals 0 down to y equals 3. Then what I know is the x values are going to be all 1. And I'm looking for cells that are going to be either this 0 cell or this 1 cell. So in my mind, I'm going to either look for like the x value for the left cell is maybe like x1 minus 1. And then the x value for the right cell is just x1 by itself, because if I'm feeding 1 into here, that'll give me that cell right there. And then the y value for the cells is going to range from, you know, whatever the min value of these two is to the max value of what those two are. So we're just going to write that the way we did it. So, you know, y start is maybe the min between y1 and y2, and y stop is going to be maybe the max. So then we're going to range over those y values, y start to y stop. And then for the cell that's to the left, we're going to have to get that one first. So let's do left cell. And again, I can use my get cell helper. and the x value is going to be x of the left cell, and the y value is going to be y. And then what I want to do here is, if I have a left cell, so if I fed in, so like let's say x1 is 0, so they're running a wire down this wall. I'm not sure why they would run a wire down the wall, but let's say they did, or maybe it started here. But anyways, let's say x is 0. I subtract 1 from it. I'm going to get a negative 1. My get cell helper, so if you look at this get cell helper, negative 1, I'm going to return none. So I have to handle that. So back here when I'm running these wires, if I did get a left cell, so if it's not equal to none, then I'm going to take the left cell and I'm going to set the right-hand side equal to false, because that's where my wire is. And then I'm going to do the same thing with the right cell. So the right cell is going to be self get cell, and it's the x right cell value and y. And again, if I'm along this edge, I might not have a cell. So if right cell is not equal to none, then I'm going to go ahead and set the right cell, and it's going to be, so it's the right hand side of the line, so it's the left edge, and I'm going to set it to false because there's a wire there. So I think with this we've handled kind of the vertical wire case, and then it's going to be very symmetrical. So I think I'm just going to copy and paste, and we'll rename some variables. Let's get the horizontal wire case. So the horizontal wire, instead of x, we're going to use y values here, and it's going to be y1 and y1, and then x is going to be x start, and it's going to be the minimum of x to x, 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 and then we're going to range x from x start, x stop, and then we're not going to get the left cell, so this is going to be either, I should rename these. So y, this is the top cell, and this will be the bottom cell. So top cell is going to be the x value, and for y we're going to use the y top cell, and we're subtracting this 1 again. This is worrisome again, because if they start here, subtract 1, I'm off the board. So this top cell may or may not be none, but if it isn't none, then we're going to set, so horizontal line, the top cell, we're going to set the bottom edge to false. And then same thing here. So this is going to be the bottom cell. If I get a bottom cell back when I do the query, I'm actually going to set the top edge, but I have to adjust my x values and my y values. So I think now that we have wires, we should be in business for this. So I'm going to run our test again, and we got an error, okay, on here. Oh yeah, need my double equals, thank you. Let's try that again. Okay, everything ran, but I got an error. Let's see what the error is. Okay, so found out what the issue is. Wires, if you remember the format of wires, wires is the list of a list. So what I need to do is, when I'm given this, I need to loop over all the wires in here. So for wire and wires, and then all of this stuff below, we'll shift over 1. And then I'm going to get my x values and the y values from each wire. And now I can get rid of my debugging statements here. I should be able to turn this all back on. It should work, hopefully. So we are all commented out from here down. So take this area. Oops, too far. And see if I uncomment it all like that. And I don't need this print statement anymore. Let's see how this looks. Wrong answer. I got the wrong answer, which is fine because I'm not providing an answer, but I should have the walls now. So let's just see. So the whole purpose here of laying down these wires is so now I can see the walls, and this first grid should look something like this. And so I can see this wall, which looks like an L. I can see that here. I can see this thing, it comes up and it kind of has a T, and then there's a box here and a box there. So I think what we've got is all the representation for the walls. So this is looking pretty good. And I think we've got this kind of grid helper, this grid class now, that when we load in the wires and we load in the dimensions of it, it can visually represent the walls. So now that we have this object grid, it's kind of representing the world, we need to carry on with our solution. What I feel like I want to be able to have is, something called maybe Pathfinder that takes kind of this grid, and then I ask it for the shortest path. So if I were going to write what I want, I think it's going to look something like this. I'm going to have a Pathfinder, and I'm going to create it, and we'll just call it the shortest path finder. I'm going to feed my grid into it, so now it knows what the world looks like. And then I'm going to ask it for the shortest path. And I'm going to feed maybe the starting values. So keep it a little more dynamic instead of just hard coding, always starting here at 0, 0. We'll feed it in. So I'm going to feed in 0, 0. So it's going to return me kind of the shortest path. I don't know what the answer looks like yet because I don't know what this looks like yet. I don't know what this looks like yet, but I know I need one of these. Okay, so I feel like I need this class here. And that class is going to be created here. And it's going to have a constructor that takes in a grid. And for now, we're just going to save it off to the side. And then I'm going to have some function, or some method on this class called shortest path. And it's going to take the X and the Y starting value, and it's going to do something. It's going to return some shortest path variable. So I feel like that's kind of where we're headed here. So although this is where I want to land, I think there's something intermediate. So if I look at this, I start here, I want something to track my path. So I'm going to start at this cell, and then maybe it's going to go down this cell, and down this cell, and down this cell, to the right, to the right, to the right, up, left, left. So I want to know what this path looks like. And so I think we're going to have some kind of object that tracks what the path is. So we'll create another class called path. I don't know what's all in this path yet, but I feel like we need something to kind of encapsulate that knowledge of a path. And just give it a constructor for now. I don't even know what's going to feed into the constructor, but let's start with that. And so I think inside this path, I think we're going to have a path variable, which we'll just call it a list for now. But this is going to be a list of, it's going to look like a list of maybe X and Y values. So, for our current example, it would be 0, 0. And then the next one would be, and maybe it's a list of a list, let's say 0, 0. And then the next one would be, because here I'm at 0, I'm going to go down to this one. So it'll be 0, 1. And then the next XY, I'm going to go 0, 2. And so you can see kind of the cells that I'm traveling along this path. And then I think I also maybe want to track the directions. Because at some point, it would be nice for me to be able to see something like the first step was down, and then it went down again, and then it went down again, and then it went right. And so visually, I would have kind of that progression of how I moved along with the cells and what the values are. So I think that's what we're at. Okay, so I kind of feel like this will give me the data for path. We're going to have to fill out kind of some of the functions in a second. But let's come back to here. So we're just working this. So creating this class called shortest path finder, and I'm feeding in the grid, I'm saving it, and then I'm calling some function called shortest path. Here at some endpoint, I'm going to return the shortest path, and I know that my return value on this thing is the number. It's an integer. It's the number of moves required. So let's figure this out. So we're going to return shortest path, whatever this is. I'm assuming it's going to be one of these things. And we're going to have number of moves on this. And for that, I'm going to return the length of this thing. But I think maybe that's one too many. So this is the initial, this is where I was placed in the world. I was born there. And my first move is actually here. So this will have, say, 3 elements. But I don't want to return 3. I want to return just 2 here. So it's always going to be that. And so down here, then I should be able to use this number of moves function. Number of moves. So shortest path, I don't know what it looks like, but let's say shortest path is going to be one of these for now. So we're just going to return it. And let's see if we're functional. Some error. All right, number of moves takes 0 position arguments, but 1 was given. That's right. I often forget this self. All right, so we're not getting an error. The return value is a -1 because this was a 0 and I got a -1 there. Somehow I got one answer right. Oh, because this grid's totally blocked off. I can never get to the finish. And it did say the minimum is required to get left of the bottom square without stepping on the wire, or -1 if it's impossible to get there. So if it's impossible, I return a -1, so I kind of won that one by default. But anyway, let's carry on with some logic here. So I like where we're headed here. This feels very object-oriented. So I've got this thing going, and let's see what we can do with it now. I've got shortest path finder, and I've got this path. What I want to do is, this is my initial position. So I think I'm going to set this initially to none, because I don't really know what the shortest path is yet. And then down here, I can do this if shortest path is equal to none. That means I didn't find the shortest path because I couldn't get there. I'm going to return my -1 value, or I can return that. So that feels a little bit cleaner. And then what I need to do now is I'm going to have a start path. And my start path is going to be a path instance. But essentially now I need to be able to tell it that I'm starting in this cell, XY, which is going to be a 0, 0 by default, but at least we can feed it in. So I got a couple of choices. I can either do something like this, feed that in, or I can say something like start path, and then maybe set initial cell, something like that. I'm kind of leaning towards this second one. I think that feels a little cleaner. So I'm going to implement that. So we're going to make this a function on here. All right, so set the initial cell. So all we're going to do here is we're going to take the path and we're going to append a point at this X and Y value. And That should be all we have to do. So we're just setting the initial position. This is our path. We're setting it right there. So let's think about what we need to find the shortest path. So, I have this path object. It's going to hold kind of all the information here of where I'm at and where I've been. I think some of the logic that we know for sure is, I don't want to backtrack ever. So for example, if I came down this path here on this side, my next move isn't going backwards. So I want to be able to make sure I don't go backwards. So if I've already explored a cell, I don't want to go back to the cell. I also want to be able to kind of determine which directions to go. So let's just take it step by step. So I'm here. I want to be able to ask the cell which direction I can move. And in this particular case, I can't move to the left, I can't move top, I can't move up, and I can't move right. So I can only move down. And so I ask the cell which directions I can move. So I think that that's a step. So given the current position, what are the allowed directions? So that's definitely a step. Once I know the allowed directions, I think what I'm going to do is, in these particular cases, a lot of times it's just I'm moving one cell, but like when I get to here, I could go to the right or I could go up. And so I'm going to have to be able to have a number of paths, I think. So given that, like once I follow this thing around a little bit, I'm going to have a path to the right and a path up, and I need to be able to track and explore both paths. So maybe I need to say something like there's a variable path to explore, which is a list. And the first thing I'm going to do is I'm going to stick our starting path on that list. So I pin that to the list right there. I think that's a good start. Now, while I have paths to explore, so that's a good way to write that. So while this length of paths to explore is greater than 0, then I need to do the stuff on the inside of here. So given kind of the current position, what are the allowed directions? So let's find the allowed directions. So my current position, I need to be able to get that from the path. And so up here, I think I'll just have another helper method. And this is always going to return the last element. And we're going to get this current position. And that'll give me the XY values. But I need to know what this path is first. So I got this path to explore. I think what we're going to do is pop a path off the end of paths to explore. And I think, I'm not sure if I want to take it off the end or the beginning, but we'll leave it off the end first. And we'll come back to this. And the reason I think that this is a question mark is I think as we're going down and we're starting to explore, when we get multiple paths here, which one do we want? So let's say we have a path that's here, and I can explore to the right essentially, or I have a path that's over here. I think I want to go with this kind of longer path first, this deeper path, because that'll get me kind of close to the end, but I still have to explore all the paths to know if they're smallest. Anyways, so I'm not sure if we want to do the first or the last, so we'll pop one off. All right, so now we can get to this bit of logic here. So I got the current position. What are the allowed positions or allowed the directions? So I know I'm in this cell to start with. I want to ask the grid, which directions can I go? Up, right, down, or left? And the one to tell me that is definitely the grid. And I think all the grid needs to know is an X and a Y coordinate. So that would be current position. I guess the index is here. Okay, so let's kind of scroll in there a little bit. Let's just make it a little bit longer. Here we go. Okay, so I need to write this function now. So I go back up to my grid. Just insert it in here. Okay, so first thing I'm going to use my helper. I'm going to get the cell. And if this is none, which it can return, I'm going to return none. Sometimes I like this logic. I think what I'm going to do here is I'm going to write allowed directions because I want to be able to get this. I don't know what it is. It's going to set as an empty list. If it's none, I'm going to return that empty list. Otherwise, what I'm going to do is peek into the cell, and I'm going to be able to say, if cell top, remember this is a Boolean, it tells me if that wall's open or not. So if that's true, all right, let's go back and just revisit here what the cell, when we created this grid, we initially set all these values to true, and that meant that you could go in that direction. So there was no wall there. So can you move in that direction, true or false? And Then we set up the walls. So along the walls, we set this as false because you can't go in that direction. And then we did the same thing with the wires. We set the values to false, so you cannot go in that direction. So for our helper allowed directions, if the cell top is equal to true, and I don't need to write this, but this is what this is, right? So it's equal to true, and I don't need to write that. Then allow directions, I can append kind of an up. It's kind of feels a little hokey. I feel like I want to be able to append something else, but we're just going to run with this for now. Up, if cell, right, and allow directions. These are my movements. I can move to the right. If cell bottom, yeah, it's kind of weird. Let me pluralize that. Down. So right, left, I got left, I guess. Okay, so when I'm done, I'm going to return these allowed directions. So I'm asking the cell again which directions I can move, and it's just based upon the wall. So if the wall says true, then I can move in that direction. If it says false, that means there's a wall there and I cannot move in that direction. So what are the allowed directions? So once I'm down here, I should be able to see the allowed directions right there. All right, so now what I've got is I've got this allowed directions array. And again, this is going to be, up, down, left, or right, but I don't necessarily feel like I have to actually take action and move in those directions. So for each maybe direction here. All right, so for each of these directions, I think we have a number of steps here. So first I want to ask the path, what's our next, like given that direction and given our current position, what's our next position? So we'll get the next position. And then I think given, my current position, and it says, say, imagine it says down, my next position is going to be here. Given this, if I haven't already explored that next position, then I think I want to add it to my path and I want to explore it. So if not already explored, then explore that direction. All right, so I think this is kind of what we're looking at. So let's take care of this, get next position. So I want to be able to ask the path this. So given a direction, what's the next position? So we can find our current position using our helper. Just to add a little protection here, if they don't set the initial cell, this thing's going to be empty. That's going to be weird. So I'm going to return this if, I guess, the length of the path is greater than 0. Else, we're going to return none. I think that's probably a little safer here. And then what I can do is, if the current position is equal to none, then I'm going to return none. So I know when I say get next position, I get the current position. If I don't have one, I'm going to return none. Otherwise, I'm going to use the moves. In these directions, again, this is kind of hokey, but we have these directions right top. Bottom, no. And again, it wasn't top, it was up, down, left, right. Okay, let's fill this logic in here a little bit. So I'm going to extract out kind of our current X and current Y. So current X is going to be the current position. It's a list. The first item is the X position. The current Y is the current position, the second one. And then here, if I'm moving up, what I want to do is I want to say the current Y is minus equal 1. Moving down, current Y is plus equal to 1. And current X, moving to the left, is minus equal 1, subtract 1. And current X is plus 1. So I'm going to return a new position where I've adjusted it based upon our direction of travel. And I feel like I need to be able to add some constraints. I mean, I don't want it to go off the edge, but can it ever really go off the edge? So if I got my walls defined correctly and I'm getting correct up, down, left, or right indications, I should never really be able to move off this grid. So maybe I don't need to double check that, so I'm going to leave it the way it is for now. But that gets me my next position, so let's call that down here. So it's a member of the path. So our current path has one of these variables, or methods I should say, and all I'm going to feed is in a direction. So at this point, I'm actually getting an XY value. Then if it's not explored, then I want to explore that direction. So I need to be able to say something like, if the path is already explored, and I feed this in this position, then I will do something. In fact, I want to do, if it's not, so if this path is not explored, if it's not already explored, then I'm going to do something here with it. Otherwise, if it's already explored, I'm not going to go in that direction at all. I forgot what I have to do next, but let's do this. So this is the path again. We're actually asking the path if this position has been explored. So I'll put it up in here. Let's just add it above here. And we're getting some position. What does it mean if it's already explored? So that means that that position should already be in our path list somewhere, right? So we should have this list of paths. And so I'm going to have one of these being passed in. And if like 0, 0 is already in, then it's already explored. So I can return position in paths. So that should give me an indication of whether or not that this new position has already been explored. If it's in the path, then we've already kind of traversed there, and we're not going to circle back and allow any kind of backtracking, because any backtracking that you can do, that never leads to kind of the shortest path. So down here, I think this function will work. And then what do we want to do next? So what does that mean to explore that direction? So we have this list of paths to explore. I'm thinking what I'll do is I'll just keep adding paths to explore. So I pop one off. So popping this path off, that means that, let's say we're here on this cell and it has all this information with it. What I need to do now is I'm going to move this direction. So that's my new cell. And I'm going to put this new path, which is a clone of this existing one, but I'm going to add something to it. So I think that's what I do is I clone current path, add, or make the move, I guess, move to next position, move to next position, and then I add it to the paths to explore. I think that's our logic for this. So I come in here, I got a direction, I get the next position. If this next position, if it's not already explored, I'm going to clone the current path, move then this clone to this next position, and then I add it to the paths here. So then this will just keep looping, and I'll keep exploring paths that aren't been explored. So let's see if we can get this to work here. All right, so I have this path just right at the top. I'm just going to add a clone method. And what is it going to do? It's going to be a new path. But now I need to get my data into that new path. And the data I have to clone are paths and directions, and that's it. Nothing else in here. So I think what we should take on our constructor is a current set of paths, which will set to none, and maybe directions also. Set that to none. So then instead of just blindly initialize into array, we'll do is we'll set it to path if path is not equal to none, else we'll go in this direction. And we'll do the same thing here. Set it to directions if directions is not equal to none, else we'll initialize an empty one. All right, so now cloning makes this a little easier, because then I think I can just return this. Path, self.path, and self.directions. That'll give me a new one of these. Okay, so cloning I think is easy. So this new path, and I want to move to the next position. And I feel like I want to call it move, but then what I really need here is, I don't really need the next position, I just kind of need this direction. So I may have to refactor here a little bit, but I feel like I want to just put in something like that. I want to say move to this new direction. And we'll take care of that in a second here. But then, once I've done that, then I have this path to explore. I want to append this new path to the end. And we haven't run our test in a while, we're in kind of this funky state where nothing's really going to work. But let's just see here in a second. I want to add this move. It's got to add to the path. What does that mean? I've got this get next position, which has a direction in it also, and I'm also going to have a move, which is probably going to use some of that same logic. So let's start writing this and see what we end up with. Move So moving, what does move mean? It means I'm going to add a direction to here, and I'm going to add another node to our path. So the first part's easy. Self.directions, append direction. Now I need to update the paths. This, I could call this and get my new position back, but I've already called it once down here. It feels a little inefficient. So the way it's set up now, I feel like I only want to put direction in there, but then I'd have to recall this. So maybe for now, I'm going to just put next position here also. Not that one, I guess this one. All right, so I feel like that's probably pretty good, even though I feel like I don't feel like I need to pass both these in, because they both, once I have directions, I can calculate this, but I've already calculated it once. I don't want to recalculate it again. So I think we'll just keep it like that. And I've got this new path here, path to explore. So let's just run this. Let's see if we have any errors here. So I'm going the wrong answers. No bugs, exceptions, error output, it's empty, console output. I'm still getting my grid. What can we look at next? So I'm saying shortest path, go find it. Here's the shortest path right here. So I never set this again, right? So let's maybe try to look and see if we can set this. Shortest path. So the current path, if you recall, the path has number of moves in it. So if you recall, this path has number of moves. So let's say if path dot, I guess if shortest path, if it's equal to none, or path dot number of moves is less than shortest path dot number of moves, then I think the shortest path, we reset it, right? I don't know if that should go at the end or the beginning, but so this path, I pop it off, and now I'm going to set this up. Let's just see what we get. Some answers here. Wrong answer. I'm getting some answers now. My 11 versus 26. I suppose so. This, I don't want to do this yet. So this is kind of in the right direction, but the logic is a little off, right? So I only want to do this if the path is kind of complete, right? So if I pop this path off and I'm in the end square, so if this path is complete, then I want to do all of this. Otherwise, I don't want to track this. This is not the path I want to track yet. So I need to get this logic if the path is complete, but whose responsibility is it to know if this path is complete? I don't think it's the grid. I think that the only thing that really knows is this path finder. And right now, the shortest path, we're saying from this position, and I think that's what we have to do is, this is the start X and the start Y. And I think I need to feed in the end X. So where's the finish line? And the end Y. And so now this is going to be start X and start Y. I think that's the only place I use that here. But now I can say if this path, and I need the current position, so I'm also do this under here. Let's move this down here. Okay, messy, okay. And I'll move this comment, because this comment really goes with this. All right, so path. So the current position, that's the X value, is equal to the end X, and the current position Y value is equal to end Y. Then I know that we're at the end, right? So somehow we've made it to the last square. And if the shortest path is equal to none, or this path never moves, I think now we're tracking the shortest path, right? So this one means we are at the end square. It's going to roll off. Let's put it here. So we are at the end cell. And if we're at the end cell and this path is shorter than our shortest path, then we track it. Let's run our test. Let's see what that looks like. Okay, we have I switched between a number of languages, and that always tricks me up, but fix that. Okay, execution error. missing 2 parameters. Oh, that's why I have to feed these in. So what are the 2 parameters? So x is 0, 0, and then it's going to be grid dot width and the grid dot height. That should do it, right? So this width is 8. So width is 8, and then my last cell is 0, 1, 2, 3, 4, 5, 6, 7. So I need to subtract 1. Subtract 1 from both these. That's the lower right-hand corner. So that's the end. Always, that's by definition. So I run this. I got 2 out of 7 tests passing. -1, 26. Okay, so not passing yet, but somewhere. It feels like we're close. So this path to explore is my list of paths I need, and I'm going to initiate this with just the initial path. And then as I go through these, as this is greater than 0, I pop one off. That's my current path. I get the current position. If I'm at the end square, then I say the shortest path is that. Oh, here, if I'm at the end square, I think I can continue. I don't need to do any of the stuff below here. All right, so if we're at the end, I don't have to go and figure out any other stuff down here. That path is complete. So let's run them again. Let's see what we get now. So I'm still returning -1, so that didn't answer. Let's see. Allowed directions. Given the current direction, or given the current position, we're asking the grid for what are my allowed directions. And so I'm seeing bottom, top, all of that stuff. Let's maybe just do some prints here. Print my current position and allowed directions. Get some more debugging here. So what I got now is print the grid 0, 0, and it says I can go down. So I'm here 0, 0. I can go down. That's right. And then my next one is I'm at 0, 1, and this one says I can go up or I can go down, and that makes sense. So I think that this is good. If I'm at 0, 2, that's 0, 1, 2. I can go up or down. I'm at 0, 3. I can go up or right. Up or right. Okay. These are all good. I think these are good. I think that this value checks out, so I don't think I need that anymore. For each of these directions now, the next position. So let's test this. I want to print current position, direction, and next position. See what those look like. So current position 0, 0. I'm moving down, and my next position is going to be 0, 1. So I think that's right. 0, 1. Next position is up. I'll be back at 0, 0. 0, 1 going down is I'm at 0, 2. So I think that's going right there. If I move to the right, I'm expecting to add 1 to x, which I do. If I move to the left, I am expecting to subtract 1, and I don't see the subtracting 1 on the left. So let's get the next position, takes the direction, and if the direction is called left, is that what I'm feeding in? Left? Yeah, left. Current x minus equal 1. So I should be subtracting 1. All right, so I took a little break, and this is where we're at still. Remember, getting some funkiness here. So when we run this test, and I got this print statement right here. When I run this test, I'm not getting increments the way I'm thinking. So if I'm at 0, 0 and I go down, I should increase y by 1. That makes sense. Up, I should decrease y by 1. That makes sense. Down, that one makes sense. Up, that one makes sense. That makes sense. This one makes sense. Right, I increase x by 1. Yep, right, increase x by 1. Left, this is where I start to run into issues. It's like 1, I should have subtracted 1 here. And if I look up in our path, this is the logic. I don't see any issues with the logic. I'm thinking maybe what happens is when I clone, am I actually cloning? I don't think I'm really cloning here. This should be a copy of path and a copy of that. Does that fix our problem? Let's take a look here. All right, we've exceeded some output limits, but let's just see. 0 goes 1, 1 goes to 0, going down, this goes to 2, going up, this goes to 1, going down, this goes to 3, going up, this goes to 2, going right, this goes to 1, going right, this goes to 1, here we go, going left, this goes to 0, going right, this goes to 3. Now it looks like I'm tracking. So I think the issue wasn't really in our move.code, our move code, but more in this clone. I was getting old copies of these arrays and I wasn't really indexing them correctly. So anyways, I think that fixes our issue. So let's go ahead and go back down here. We can take care of this print statement. We don't need that in there anymore. Let's run the test. Let's see where we end up. Okay, so execution time limit exceeded. So we need to go quicker. but it looks like we're getting the right answers. So the return values are 26, return value is 6, 0, -1. Okay, so we have to be faster. So I think there certainly are some reasons why we don't have to explore a path, right? So given a path, if this is already longer than our shortest path, then I can exit early. It doesn't really matter to me, right? I think I can write that code right here. So if our current path, number of moves, is greater than or equal to our shortest path, number of moves, then I don't do anything more with this one. And I suppose I have to check if shortest path is not equal to none and that. So this is kind of one short circuit path. So I'm getting out early because I have a shortest path. I know that this current thing is already longer than my shortest path. I can leave early. See what that gets us. We're still time limited. So just to be clear, if this is if our current path is already longer than our shortest one, there's no need to go further. We're done with that one. Maybe one more speed up that we can do in here is, given this path, and no matter what cell I'm on, so let's say I'm in this cell right here, if my current number of moves that I got, which would be 1, 2, 3, 4, 5, 6, maybe 7 to this one. So if I'm 7 moves in on this current square, but I already have a path that reached that current square before I did, then I can short circuit. That making sense? So it's not just necessarily shorter than the shortest path, but also if any other paths have reached kind of the square I'm on, that's the logic. I think we'll short circuit a lot of squares. So if any other paths have reached the cell in fewer moves, then there's no need to explore anymore. So to make this work, I will use the path's number of moves, but then I also need to track kind of the smallest number of moves to get to a certain cell. Where do I want to put that at? I feel like I can add it to the grid. So let's look and see what the grid looks like right now. So here's the top, right, small. What if I add another attribute here? And min steps. Set it to none. That's it for initializing it. So for this one, I think I'm going to have to do this under the current position. So here I can get the current cell from the grid. Takes an X and a Y value, so we'll feed in the current position. And then the current minimum steps will be this current cell and min steps, I think it's called. That's what I call it, right? Min steps. Okay, so then my logic is if min steps is not equal to none, and I think that's the logic, but now I have to be able to set min steps here. So this current cell, so if min steps is equal to none, or my current number of moves is less than min steps, then I want to take this current cell, min steps, and set it equal to my current number of moves. I think this is a little bit complex, but let's go through it real quick. I think this is right. So if any other paths have reached the cell but in fewer moves, then there's no need to explore. So I'm getting the current cell from the grid, and then I get the minimum number of steps because this is inside the cell data now. If it's not none, I compare it to the number of moves. If it's greater than, this is my exit early, I'm out of here. If it's not greater than, I have an opportunity to set it. So if it's equal to none and, or, let's do or, it's or, right? So if it's equal to none, or my number of moves is less than the minimum steps, then I must set it. And that way I'm keeping it up to date. Let's run this. All right, so it looks like we have all the tests are passing. That last little bit, I feel like it should be refactored a little bit. It's a little chunky here, but let's keep that there. What's this one? This one is if at the end, no need to explore more. So these are all kind of those short circuit, we need to get out of here early type of things. And then if I didn't short circuit, then I'm going to get the number of directions and I'm going to add more paths to it and I'll explore some more. All right, so I run this, I didn't change anything. All these tests are passing. If I submit it, execution time limit. Okay, so it looks like we're working towards the right direction, but the hidden test I only got 3 out of 7. So I'm in kind of post-production here, and I'm looking at how long this video has become. I didn't realize that this was, altogether almost an hour and a half or so of kind of me just kind of working on this puzzle. I have fun doing these kinds of things, but I'm not so sure that people have an appetite for an hour and a half long video. So I'm going to cut this right here. And if you are interested in a part 2 where maybe I try to optimize this a little bit, you can let me know in the comments and I can come back and revisit this.